Hey guys, welcome to the shop. This video is primarily a lessons learned and sort of after action report on this cutter design and the results of the project. So if you enjoy this content, please like, comment, subscribe, and share. This channel's been growing pretty steadily, and that's awesome, and I'm hoping to keep up the good work. Now, long story short, I think I made a handful of mistakes on this project. I think the first one that really set me back and wasted time was using oversized O1 rod. Now, I buy that for general purpose tool making because the tolerance on it is plus 1,000ths to plus 30,000ths, and that's really irrelevant for most tools. But this one had to fit in a collet. So that added an extra step, and you can see the step down shank where I turned it down. And my second mistake on this project was not locking the cross slide in the compound. So the cutter grabbed on my finish pass, and now that shank is 1,000th of an inch undersized. So that was fine. It still held in the collet and did the job it needed, but that was a mistake there. Secondly, you can see there's a very, very short neck on this cutter, and that wound up being somewhat problematic in that um, I didn't fully finish the backside in the relief of the cutter, so I did get quite a lot of chip welding from rubbing there. Now, none of these are really insurmountable issues. Obviously, it worked, and I think next time what I'm going to do is dress a wheel on my surface grinder, and with the longer neck, I should be able to quite easily grind the relief that way instead of doing it by hand. Now, the methods I used, you probably could have made this cutter entirely on a lathe and just with a hand file. You didn't need to use a milling machine at any point. Uh, there's historical model engineering references which I don't have in front of me and don't have any good book names to recommend, but I do recall seeing someone making dovetails entirely on a lathe, making the cutter wholly on the lathe and filing, and cutting dovetails on the lathe and filing. So this is not a technically complex task to accomplish, but it does require a little bit of forethought and planning. Now, going forward, I know I'm going to have to make more of these. I think I'm going to purchase a tight tolerance stock for future cutters because that's just going to make everything quite a bit easier. And I think I'm also going to invest a little bit in better heat treating equipment. The long term goal for the shop is in order of purchase, I think a inexpensive MIG welder, a inexpensive 4x6 bandsaw, and then a heat treat oven. It's the All of those tools really will speed up a lot of the work I do. As of this time of recording and posting of this video, if I have to fuse metals, I either have to outsource it to someone with a welder, or I braze it, or gas weld it. Uh, Gas welding is a pretty tedious process, and I'm not very good at it. It Dealing with the oxyacetylene torch in a hose is a lot like arm wrestling a bear, and it's less of a challenge with brazing. With gas welding, the heat involved, I do have some trouble with it. Now, overall, this project was a success. Now, for just kind of my outro, I'm just going to post a video of the finished part. Everything worked as intended. The customer seemed quite pleased with the result. Now, the overall result of this project was positive. I think I did learn a lot. This is my first dovetail cutter. I have made D-bits in the past, which I think I'm going to post some information on. And also, I think one of the things I will probably do is a better explanation of heat treating. I skipped over a lot of parts of what is required in this video. Now, you really do want to normalize and stress relieve the part. Now, because of I did relatively light machining removal and I made sure the cross section was fairly even. I didn't get much distortion, and I skipped a step called normalizing it, which is bringing it up past its critical transformation temperature, holding it there, and then allowing it to air cool. That relieves machining stress, and it improves the lattice structure so it hardens more evenly. Uh, as a time concession, what I did in this case is people will either often triple normalize or triple quench. So I just did it twice because, in my experience, the simply quenching once improves your hardness and toughness so much because it every time you transform past a critical temperature, which is about 1500 Fahrenheit plus or minus, you get a change in the structure, and it refines it, and we can get into the whole like spheroid, cementite, and all of martensite and all of the substructures of steel, but that's a bit off in the weeds. Now that just improves your toughness, and I'm pleasantly surprised that this didn't chip. I did not have high hopes for how it was heat treated entirely by eye, and then sticking it in an uncontrolled toaster oven for the tempering process. So overall, again, project was a success. I think this was really interesting, and I'm hoping to build more on this series. And I am launching on, I think it's the 28th or 27th, a new series which is kind of like an intro to shop tools and basic machining, which I'm going to try and make as accessible as possible to the layman. And I hope to have one video a week on that, and then I think I'm going to do one more technically complex video. The upload schedule going forward, I think I'm shooting for 3 videos a week, full length, 5 to 20 minutes. But I think realistically it's going to hover around 2 because I can't let this channel get in the way of running the shop. So again, thank you guys for watching. I hope you really enjoyed this and learned with me. So